Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good morning, afternoon, or evening, wherever you may be. It is my great pleasure to welcome here to Microsoft Research in Redmond, Ben Schneiderman. Ben, for many of you, needs no introduction. For those who need some introduction, you should know that Ben's contributions to information visualization and computer science are, well, significant. And he is here to tell us today about his work related to the analysis and visualization of directed graphs, something of great relevance to those of us interested in social networks and social network theory. So with no further ado, Dr. Schneiderman.
Thank you, Mark. A great pleasure to be here. Truly mean that. I love to come and talk with Mark, and it's better than talking on the phone. Appreciate the support Mark's arranged from Microsoft to support some of this work. It's also a rich, satisfying collaborations with two PhD students whose work I'm focusing on. And this is a narrowly focused talk today. Usually I talk about the broad vision about HCI and all the great things we've done in the Human-Computer Interaction Lab, which I'm very proud of. And this group at the University of Maryland is celebrating its 25th anniversary, so we have lots of history to talk about. But I'll let you visit the website and and learn about all of those things. So the focus narrowly is about network visualization. And if you want to learn about network visualization, all the many ways people have done it, there's a wonderful website called visualcomplexity.com where you can look at all the varieties of these projects and get descriptions of them, samples, and then links to the actual projects. And there's actually, if you want the whole, well, not whole, but 360 of them arrayed in a wonderful way, you'll get to see the rich, colorful variety of ways that people do network visualization, a currently hot topic of interest for many people in InfoViz. For me, I've sort of kept this challenge off till we got a little more mature in terms of the technologies. We've worked on hierarchical visualizations, but tree maps and other strategies. We worked on temporal data, Time Searcher 1, 2, and 3. We worked on multidimensional data with Spotfire becoming a successful 200-person company. We've worked on, clustering strategies for multidimensional data with the Hierarchical Clustering Explorer, and now we are ready to take on the great monster of network visualization. Now, if you look at all these, I mean, in a way, one can say, what could you possibly contribute? There are 360 great projects that have gotten people PhDs and founded companies and all kinds of great things going on. Well, if you take a look, you'll find that there's, as we analyzed these, and we looked at the first 100 of them and actually counted the strategies for doing them, the most popular way, the majority of ways that people do it, is force-directed. Or spring-embedded, there's a variety of annealing terms for this strategy, but basically you throw the nodes and the links out there, let them jiggle around, and let the topology of the network, as defined by the links, guide where the placement happens. There are many, 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 many variations and improvements on this. In its good moments, you get beautiful and meaningful results that have a nice visual display and also show you meaningful clusters. That's the good news. The bad news is you get bowls of spaghetti much of the time. And the bowls of spaghetti are a serious problem. To my great dismay and alarm, most people don't seem troubled by this. They think it's beautiful, and they print up big posters, and they have museum exhibits that show this, and the New York Times publishes this crap. And, it's presented as, oh, it's science, it's rich, and maybe, as Mark suggested, it's the bubble chamber of photos of the social network world, which we hope we can make some sense of. Okay? Now, the second most common way of presenting networks are geographically based. These are actually far superior in making sense out of them. There's a stable and meaningful substrate. There's a familiar map of the USA over here. And here there's a map of London. I'm a little troubled that you can't see this. And I'm, for the sake of the audience here, you ought to see these too. But they're quite beautiful and they're meaningful. This shows telephone communications emerging out of Florida to different places. You can see each of the places it goes to. You can see there's more to Chicago and New York than there are to Oklahoma. And there's lots of interesting results that you can extract from that. So geographical are very popular, are second most popular. Circular layouts were third. And sometimes they're meaningful. This is actually a circle of the globe looking down from the North Pole. And this is North America, Europe, and Japan. And these are internet connections. So you get some meaningful sense. The circle as actually a map, if you wish, of the planet. This one has less meaningfulness. It looks pretty. It has a sense of order. And it sort of arrays things out in multiple circular. Temporal layouts are important in many areas. This is a famous one called historiographs. Gene Garfield originated this, that show reference patterns of journal documents. So you're always referencing upwards to previous ones in time. And if you can see the dates, 57, 56, 55, 54, back to the earliest paper in 1944. So there is a meaningful structure to this that is helpful. A very small number of those visual complexity ones use a temporal layout, even though it's highly beneficial. Others productively employ a kind of clustering to make some sense out of it. Either the clusters are created manually by hand or extracted by algorithm. This is from the work I'm going to show you. But they provide an organization and a structure to be able to drill down and see interesting components. And so clustering is potentially a good idea, and recent work has found good algorithmic ways to make clusters which do not overlap, which separate things adequately, etc. Now, I'm going to come back to the layout based on node attributes, which is one of the strategies I'm going to talk to you about. There are other very radically different approaches which don't do node link diagrams at all, but matrix-based approaches, and then tabular textual. Bangshin will recognize the paper lens, note lens, or not note lens, but what is it? NetLens, right. Versions where you are looking at a network and you are navigating among steps of a network. But since the textual content is so powerful, it's important to have it there, and the attributes of the nodes in groups are important to look at there. So that's the sort of general lay of the land. But as I said, I'm not really too happy, and especially unhappy with the most popular technique, the force-directed approach. And so, if you begin to work in this area, you sort of want to know what's the right idea. Now, some of you may know me for the what I call in a joking moment, the information-seeking mantra, which was overview first, zoom and filter, then details on demand, which was playfully included in a paper but become wildly referenced, and hundreds of references that either build on it or complain about it or parody it or extend it or do good things about it. So I thought I'd follow up the mantra with the pursuit of net viz nirvana. So if we want to know what we really wanted, we should sort of meditate a little bit on this mandala and sort of try to think about what in a space of complexity could give us a sense of order, simplicity, clarity, and calm, right? Okay. So what are the attributes of what I would like from a good visualization? And I'll offer this as a starting list. That, first of all, every node is visible. Secondly, for every node, you can count its degree. That is, the edges or links coming in or out. For every link, you can follow it from source to destination. Every link. Okay? And that clusters and outliers are identifiable. So this is kind of where I'd like to go, and this is a very loose task list, which we've elaborated on with much lengthier task lists. And Bangshin also has a task list developed with Catherine Plaisant. And Alec Aris and myself also had a different kind of much more atomic level of task list. But this gets you pretty close to the key things that people, I think, want to do, and for which different strategies are more or less effective. Okay? The clusters are nicely shown by force-directed, but not much else. Okay? And the other strategies out there don't usually give you these as they don't succeed. If you try to do this, you won't find it. So the question is how to attain net viz nirvana. Okay? That's our goal for today. And what I'm proposing to show you is two strategies. where we are working to attain it. We don't claim to have, but you will judge whether we're making progress and whether they provide constructive ways. So the first approach is semantic substrates. Okay? This is a basic idea. It's the PhD work of Alex Aris, who's making progress as we speak. The basic idea here is not to let the nodes get laid out by the force-directed approach, but to put the nodes where they belong. Okay? And that means we create nodes into regions. They belong somewhere, and they belong within each region in the right place according to the attributes of the nodes. Okay? Attributes may be categorical. I'm going to show you Supreme Court cases, Circuit Court cases, and District Court cases. They're very clear. It could be Monday, Tuesday, Wednesday, Thursday. Could be some way of grouping things that I'm going to show you. Or if they're numerical, you can bin them and have, low, medium, and high values. Okay? Then within each region, you place the nodes according to other attributes. So we're extracting from the nodes the values that are important, and we're using them to present the information. And then a very important part of this is give users control of link visibility, that they don't clutter the screen with the many thousands of links that are possible, but they only show the links that are relevant for their task at the moment. So this is very much an interactive and user-centered approach. So, this is what we want to get away from, and I just show you, even with a simple data set of 36 Supreme Court cases, which are the red dots, and 13 Circuit Court cases, the white dots, and these are the citations across them. We are working with partners in the political science department who are studying a part of law called regulatory takings. It's what happens if the government changes the laws by which your property is addressed. So, for example, typically zoning laws. If they declare your property is to be wetlands, then you can no longer build on it, but you still own it. So they didn't take it away, and do they have to compensate you for that? That's really been a central question in American law, of which there are 2,700 relevant cases and 16,000 citations among those 2,700. So that's the working corpus. Part of the project has been to work with them and extract those data sets and get the data polished and cleaned and all those things, but then to visualize it. So that's what we didn't want, and this is done with Jung and a force-directed approach. And to understand why it's particularly bad is the interesting cases are the ones that have many citations in or out, and of course they get sucked into the black hole vortex of the center, even in a tiny display like this. So the alternative is to do this. This shows two regions. This is just Supreme Court and Circuit Court cases, and they stretch from 1978 up to 2002, and they're jittered on the y direction, and so their layout, you can see there were a bunch of cases over here. It got a little quiet for a while, and there's some other cases. The size of the nodes indicates the number of out links, the number of edges, number of citations going out. That could be changed or whatever it is. And these are a small set of those 13 cases. And then you don't have any links except you can get to expose them by clicking on these boxes. So if you say, well, there's only one Supreme to Circuit, let me show it. So I show it over here. There are 18 Circuit to Circuit references, and so you can see them. And if you could see these, I hope you could see this here. I mean, I don't know that, you can see the arrows and where they go and follow them along. So that's really the simplest kind of case. If I showed you all the 260 Supreme to Supreme cases, it would be quite a mess. And so I don't even want to show you that, but I'll show you the simple way we approach it. We have a slider bar that says I'm going to restrict the range of out degree or in degrees. And so I'm only going to show you for the cases that occurred in 1986 where they point to. So now I only have 15 of those, and I can show you those, and pretty much I can follow all of them from source to destination. Okay? So, I think this is sort of the basic idea. We followed through on what we said. And you may say, well, that's all very nice for 38 nodes or so, but what about a little more? So this will show you a few. What have we got here? This example is about 400. And now we've separated Supreme Court cases, Circuit Court cases, and District Court cases. And we've imposed even more structure because in the US there are 11 circuits. And so they're laid out over here. And what you see immediately in this visualization is the green lines are circuit to circuit references that basically the circuit courts reference within their own circuit. Okay? Except that if you look at it, this one is very busy The Ninth Circuit, Northern California, is a pioneer in real estate issues, and so it has a lot of significant precedent-setting cases, and so it gets a lot of incoming links more than the other areas do. Okay? So we claim the more structure you put in about the placement of nodes gives you more information and more insight to what's happening here. If we could do the demo, we'd let you see, I think there's, well, okay, there's more interesting things you can see. If you look at the citation patterns, you'll see that, let's say I chose a set of these to look, then they would reference nearby to recent district court cases. They might reference circuit court cases of 4 or 5 years ago, but they'll reference Supreme Court cases even 25 years ago. So the half-life of cases is apparent and visible and so on. So we've given users a rich set of controls that let them expose which links, and then the slider here controls even when it's too many within a category to see them. And then what's very dramatic is the number of crossovers from one region to another region. Okay, so this seemed to be the right kind of direction. This was built, NVSS 1 was built, hand-coded and programmed by Alex in conjunction with our partners in political science. And NVS 2.0, the version the paper will appear in December issue of Information and Visualization Journal. We're just doing the revisions, final revisions on it. But basically, it's a design tool that lets you lay out the regions rather than do any programming. Describe all its attributes and their placement and their color and so on. And then you get, so now we have Circuit Court, Supreme. This was suggested actually by one of the reviewers of the early version of the paper, and we thought this was great. So they put the Supreme Court in the middle, and then you can look at Supreme references to district and Supreme references to circuit. And what you see if your eyes get trained on this kind of thing, this particular case is really different because it references a historical set in the circuit courts and also in the Supreme Court. Most of the others are up and down. They reference only recent cases. But this one is a strange beast because it has this historical review of the whole issue. So those things pop out to your eye, and it is the virtue of information visualization. It gives you answers to questions you didn't know you had. Okay? I think that's the spirit of it, that when you see these kind of things, you say, oh my, that's really pretty interesting. Now, I will admit this is still imperfect. There are problems. I mean, although here they're pretty good examples. When I trace the edge, I can follow where it goes to, but it sort of crosses under these nodes, and wouldn't we want to move them around? So we want to avoid tunneling under nodes. And there's a variety of other improvements we'd like to have, and we see some ways of gaining some opportunities there. But the basic principle seems to be in place. We've enriched the control panel so you can look at outgoing edges or incoming edges. You can restrict on years for incoming or outcoming. There's a rich set of controls. Are you getting those slides over here? You're getting, oh, no. I thought you were. Okay, anyway, so any questions about this idea or NVSS 2? This is just.
So it assumes that there is some attributes associated with the nodes using which you can lay out it.
Correct. If you have just points and edges in a total topology, then you have to work a little harder. Then you have to invent attributes, like the attributes would be the in degree, the out degree, or other properties, and you're probably forcing things. So you could put all the nodes that have high degree on the top and all the ones with low degree on the bottom. I mean, there's a lot of things you could imagine, but it's not really, I would say its payoff is modest in those cases. Its payoff is high when the nodes have lots of values, as they do if the nodes are people or documents or typical things. So, we've come to understand it. The paper also tries to suggest a set of guidelines for proper design, when these things should be aligned. I've shown you only some simple cases, but, which things should be close to one another. We sort of allow for up to 5 regions, so you want to prevent things that cross over too badly, and I'll show you some other examples in a little while, but I just wanted to get the basic idea. Yeah?
One interesting property is that all links are from left to right, because it's chronological.
In this case, references go backwards, but, there could be other things, not in journal papers, but where things go back and forth. That's right. I mean, if this were birth dates for parents and these were their children, then you'd have references the other way. I mean, so that's right. So here, you attune yourself to those things. Problems that we encountered were if the distributions were not very uniform. You'll see in case you have a highly skewed distribution, or you have a bunch of things here and then you have one outlier, which is 100 times bigger than the others, then you have all the wasted screen space problems. So you need to deal with the outliers, do logarithmic or square root transforms, and there's a variety of things to play around with, and the paper suggests the guidelines. Okay, I just want to get the basic idea here. I'm going to try to keep it to 4 o'clock for your purposes and others as well, and me to get at it here too. So the second, I'll come back to the evaluation of both of these as well. That'll give us a second pass. But the second strategy is the work of PhD student Adam Perrer, who spent 2 summers here. A wonderful student and doing very interesting work. And this has been great fun. And I think I can show you the video of this. So I'm going to focus on one of the 4 case studies that's reported in the Chi paper. I think I sent you just this morning, so you can take a look at. But this is just too good to be true. It's one of these beautiful, beautiful situations. A journalist for U.S. News and World Report, a political scientist, has been studying the patterns of voting within the U.S. Senate during the past year. And he's carefully collected the data. There are 100 U.S. senators. Okay, there have been 310 roll call votes during this past year. And actually 2 of the senators were ill and did not vote during this past year. They were hospitalized. Remember a couple of cases. So that leaves 98. Now, for every one of these, and I'll show you the video, for every one of you, draw a link between them if they voted the same way, okay, at least 180 times. Okay, so there's several thousand links over here. And this uses a force-directed approach. You throw this thing out, and I'm going to play the video, I hope. And they jiggle around red for Republicans and blue for Democrats. And it's just, an unbelievable result that, the journalist couldn't believe that we didn't rig it. But all the blue Republicans, all the blue Democrats wind up together. All the red Republicans wind up together. There are 4 Republicans who often vote with the Democrats: Olympia Snowe from Maine, Collins, Specter, and Smith. And so they got moved right over here. It's a beautiful example of force-directedness. And then there are 2 senators, Brownback and McCain, who floated off because? Correct, but how come? Because they're both running for president and they haven't been voting that much anyway. So that's right. They're just not there. Okay? So they don't, to vote in the Senate, you have to be there. Okay? So it really is this sort of too beautiful to be true. And in fact, even the special color coding, there are 2 independents, Lieberman, Sanders. I hope you can see those color distinctions. And they vote with the Democrats. And you can see some real outliers like Biden and Dodd, who, while they vote with the Democrats, they rarely vote Republican style. Okay? They have no partners in the Republican world. And, you have some Republicans who are extremists and don't vote the Democrats. But the Republicans in this voting Congress have much more crossover. Now, the other thing you'll see in this video also, if I up the requirement to 190 or 200 or 210 and 220, then the Republicans fall apart. Okay? And the Democrats hang together a little bit better, although they begin to fall apart. And you'll still see there are concentrations of a Midwest set of Democratic senators that tend to vote together. Okay, so let's see. Oh, here is where it goes. This is just to show you the static picture, that it falls apart, except there are these pair, Isaacson and Chambliss, who do vote the same way. We're up to 290 out of 310, but they've fallen apart. There are still many Democrats who vote together in the same way. This is Richard Whitehouse of Rhode Island, and when you cursor over one person, it shows you their neighboring persons, gives you a photo of the person. Click gives you the details on demand for that senator. Okay, and we hope a version of this, a stripped-down version, will wind up on the U.S. News and World website. Not too far. Actually, maybe Slate. They've sort of passed on this particular one. Slate may publish this. So, all right, let me try to do the video for you. And let's see. If I run the video, I don't think it's going to show until I do my... Yeah, are you seeing it still? Okay. All right, you want to turn the lights down here? So there we go. This is the initial throw. They're all the same, and we now start moving the slider up to have the number of shared votes, 120, 30, 40, 50, 60. And now McCain splits off because he's too busy, so he's dropped out. And now this great mass of the Democrats moving here, red Republicans moving over there. And it sort of jiggles into steady state as you get up to the 290.
There's still some Republicans over in the Democrats.
No, these are the independents. Okay, these are the 4 Republican crossovers. And now we're going to freeze it once it settles down here. We stop moving here. So now we freeze this and so we freeze the force directed, and now we continue to filter. So we don't get these wild movements. And so now we're taking away the links, and you can see the Republicans are beginning to fall apart. The Democrats still remain, and you get that nice, clean outcome. And if you look at Chambliss and who was the other one? I forgot who Chambliss is partnered with, but you get to see their patterns as well. And there's the link viz idea. And I guess if you click for details, you get Richard Whitehouse. And
So it'd be nice to have a multimodal network, which also included who gave money to whom.
oh, yeah, I mean, there's... Go to it.
Plethora.
Take it on.
Yeah.
Go, my son. And take it. But I think you got the idea. Social action is a very rich and powerful tool that impressively built. This shows you only one aspect of it. But what I hope you appreciate is this tight integration of statistical stuff over here, the slider on that one attribute, and the immediate display. In other tools like Jung and Pajek, basically you set up the statistics, then you draw the visualization, and if you want to change it, you go back to statistics, you recalculate. But here, this smooth, continuous, update is a product of Adam's excellence in programming and our thinking it through. Social action is a rich and powerful tool, which maybe I should go back to just say. Do you want to see that video again, or are we okay? All right, so let's see. Just to show some other aspects of it, oh dear. So the paper has 4 case studies. One of them is another wonderful example of working with a PhD computer scientist in Boston who's working with healthcare organizations, and their network is of boards of directors and partnerships across all New England hospitals and medical organizations, and who's connected up with whom in order to form partnerships. So the combination here is another example. There's a whole set of ways we use statistics. So this is the nodes plotting. So this is the plot of in degree versus betweenness centrality. So betweenness centrality is an important person who's strong connector, but it's pretty interesting. I may have got the axis. Oh, no, y-axis is betweenness centrality. So here's the high betweenness centrality, but essentially low degree, which is a surprise, okay? So that's a real outlier, and if you click on that node, you see who that is, okay? So the capacity to select and to see the scattergram of a pair of variables, and then to select one and see its display, and control all the visualization of those properties is a particularly rich and compelling aspect of this. Again, I'm not going to get too far. This is the community network in work with PubMed, PhD computer scientist using this tool for work at National Library of Medicine this past summer, looked at all the related documents as selected by PubMed for a set of documents, and then found interesting clusters and relationships of related documents and unrelated documents. These that are unrelated are separate kind of cluster structures. The cluster mechanism worked very nicely to be able to show these things, and resulted in a paper published that's been accepted for a conference later this year. We're also working, one of the case studies with the University of Maryland is the central node, if you will, for the Department of Homeland Security's consortium for the study, the behavioral and social science approaches to the study of terrorism and counterterrorism. And they were chosen for that because, in part, they have kept the global terror database, the GTD, of 70,000 terrorist events over the last 28 years, and a very highly curated database that has, we hope, accurate data, and social action will be the tool of choice for exploring this thing. It will be crafted to their website and be part of it. The data will be independently available, but this will be the mechanism. So if you just plot, and basically this is a bipartite graph, and has terror organizations and has countries in which they stage attacks, so you can get to see. It also has people, a variety of other things that you can examine. So you get the usual force-directed mess like this, although there are some potentially interesting clusters. And again, the point about social action, it gives you an overview first that just tells you the basic notions of what's there. Then you can rank the nodes by different attributes. You can rank the edges. You can plot the node attributes, find the communities, work by edge types, and then do all these other controls at the same time. So, for example, if you look at this and do a little bit of filtering on the betweenness centrality of some of the key characters, you do find bin Laden's way up there. He's really central to this network in a strong way. And you get to see this, by the way, because you've filtered out the ones that have low betweenness centrality, and you can rank and deal with all of those statistics. If you go a little bit further, you'll find that Muhammad Atta, who was part of the September 11th group, was also well connected over here, and he was well entrenched, and he was the one who assembled the team of 19 who ultimately led the group on September 11th. So this is sort of, I would say, a beginning stage in working with this research project, but the report tells you the story of one researcher, James Hendrickson, and how he explored this data set. So in the remaining time, I want to turn to the question of, here I've made two arguments to you, that semantic substrates and integration of statistics and visualization are good ideas for dealing with network visualization. And you say, that's nice, I hear you, but you're not a businessman, you're a scientist, so prove it. And we have a long history. I think our lab is respected not only because we build interesting things, but because we take the evaluation part very seriously. And we've run controlled studies in many circumstances, and controlled studies still can be a useful tool. We still do them when tasks are clear-cut and when the features of the interface are sort of very specific incremental changes. But when you have a whole new paradigm like the two I suggest, it's just not easy to suggest what we mean by a controlled study. And we don't believe that the 1 hour or 3 hour or even 2-day study is what we're after. We, in our experience with other tools like Spotfire over 10 years, we've come to understand that the nature of domain expertise is grand, and that the nature of tool expertise is rich, and it doesn't happen in a day. And that changing your strategies of work is not something, we find dramatic differences overnight, by the way. I mean, if you train someone on a tool and ask them to use it, they don't quite get it. But if you train someone and ask them to come back the next day, we get a much better uptake of applying the ideas in novel, the far transfer tasks. Near transfer tasks are easy to measure. It's the far transfer and the expertise that we're very much interested in. And so our goal has been to support domain experts in doing serious work. So we're talking about people working on their own problems for weeks and months. And that's the nature of what we propose here. So my reference to Science 2.0 I'll mention at the end is the sort of transition from Science 1.0 kind of thinking and work of controlled laboratory experiments that are replicable, and you can study the change in let's say the resistance of gallium arsenide crystals as you change the temperature. It's replicable. Everybody can. It's sort of a central tenet of Science 1.0. But the nature of Science 2.0, I allege, is that it's richer and deals with socio-technical systems that have people embedded in, and that we're talking about long-term phenomena. And so the idea of short-term controlled studies has many flaws, and that the kind of annoying, troubling outliers are really the interesting data. Okay? And so we want to embrace these more ethnographic, observational, and situated. That is, real people doing their own work in their own settings that they care about. Not we say, do our problem, and we'll pay you $10 if you if you do it, or $10 if you do better than everybody else. Those are mild but artificial motivations that are short-term. We're interested in people whose careers are devoted to these work and who are serious about doing it. So we propose this idea of multidimensional, in-depth, and long-term case studies. That is, domain experts and communities. We think this is a mechanism for studying Facebook and Second Life and so on, doing their own work for weeks and months. And these became known as MILCs, and Catherine Plissanton and I wrote this paper that is in the ACM Digital Library that talks about these strategies. Now, I just want to describe how we evolved into this and a few examples. These examples are all about discovery in scientific environments. They're not social creativity, but they give you an idea of what we're doing. So we had worked on a number of tools like Time Searcher, which we tried to evaluate by controlled studies, but found that it gave us not very interesting results. I mean, sometimes it provided useful evidence, but in Jinwook Seo's development of the Hierarchical Clustering Explorer, an impressive software engineering project of 72,000 lines of code over 3.5 years, and still remains a remarkable piece of work. But the central idea there, which I feel is one of my strongest contributions, is something that I called the rank by feature framework, which allows you to look for patterns in high-dimensional data spaces in a systematic way. The question that Jinwook Seo's dissertation committee said was, well, how are you going to prove to us that this tool is any good? And we proposed that he conduct 5 case studies with real users. And these were to be over a summer period, so they were to be 4 to 8 weeks. We wound up, one person dropped out, one person had to work on other things, so we had 3 good ones that followed through, and each of these PhD workers resulted in a published paper in their own discipline. So that was impressive also. The triangulation from other data was that we have many users. We asked for people to fill out a survey. We got 85 email surveys, of which 57 were complete enough to give us the right kind of analysis. And they confirmed what aspects of this tool were helpful to them. So that was a nice way of supporting what they used most. We would have also liked to have logged the data and their usage, and that's something we're doing more and more of. So it identified problems in the tools early. It gave us strong positive feedback about the benefits of the rank by feature. And that paper is published in the IEEE Transaction and Visualization Computer Graphics. So they're kind of portraits, but in reflection, we learned a lot about how to do these things. And so the next 2 times out, I think we're a little bit better in understanding what's a good case study. Okay? So in evaluating NVSS, the current paper has 2 lengthy case studies. One of them is with the political scientists that stretched out over a year as we were developing this. The other is a shorter one of 2 months with a biodiversity expert looking at food webs. That is, animals eat other kinds of animals. And if you can see, there are different, these are ectotherms, there are photoautotrophs, invertebrates, and detritus. So these are the different kinds of animals, and these are how they eat each other. And this one's a little bit elaborate and rich with data here, but you get the idea. And, many discussions about what were the attributes to plot these things on that made sense, and so the paper describes that. Here, what we were trying to prove was that the semantic substrate layouts were a payoff here. We weren't interested in showing that the sliders or a particular widget was good, but it was that the way of thinking was beneficial. So it identified a set of guidelines for the substrate design. We see that as an important product of this case study. And what was really most strong, the political scientists say that this way gave a new language for discourse, thinking about what was the right kind of substrate to see the data, whether it was Supreme Court circuit or this, whether they should be organized by date or by the majority or the strength of the win, or many, many, many things were discussed until, and having a visual medium to play with and try different things out gave them a new language for thinking about the problems they were after, which we think was a benefit. It clarified the benefits and limitations of the semantic structure. So that one will appear this December. The one that's most mature in our methodological one is with Adam Perrer in evaluating social action. Again, Democrats and Republicans. But here the question was, does integrating statistics and visualization help? Now that's a tough thing because it's not the kind of well-stated hypothesis that you'd like. But still, we became more and more concerned that these are, as opposed to ethnographic approaches to research, which basically are usually described as not having hypotheses. They're neutral observations to collect ample reports, observation, which later then someone analyzes. So, without an opinion, without a bias, without a hypothesis. We believe in hypothesis testing, and case study research methods are often described as hypothesis testing ones. And in this case, Adam followed through in a systematic way on these 4 case studies that went 4 to 8 weeks. The journalist I described, the bibliometrician, terror analyst, and the organizational analyst. And it identified the set of features, and Adam would wonderfully, especially the health organization analyst was very savvy, and he had used 8 different software tools, and he was a great fan of social action, but he kept saying, well, I need this, and 2 days later it was in, and so it went, So that's the way you get the strong feedback, because people care about what they're doing here, and they're pushing your tool beyond the limits of what other tools can do. And it was very gratifying that here's a guy who's, he's mastered 8 tools in his many consulting projects, and he was not happy with them. He actually came back to NetDraw for pieces of it, and so Adam's vigorously trying to accomplish what NetDraw did for him within this environment. Now, here's the structure that I found more compelling here, that there was a 1-hour interview to start, and we wanted to make sure people had a clear goal, a timeline on which they were going to accomplish this, and that they really cared about it and they were going to follow through. So we were weeding out the casual types here who just said, oh, that's cool, I'll try your tool. No, we wanted, you got to do this. If you had a deadline, you had to get some answer, and you were after. The journalist had a clear deadline for publishing. He wanted to get a specific answer, and he wanted to get it understanding. We then, more or less a 2-hour training period, and then there was the early use of 2 to 4 weeks where we tried to help them and train them, and then the mature use of another 2 to 4 weeks gave a different set of perspectives where they became much more demanding in their requests. And then the closing interview, the outcome, do you still want to use the tool? Did you get what you want? Are you done? Where do we go from here? And, how much will you pay me to let you keep the tool? Kind of questions. So the paper tries to describe all 4 of these in a more systematic way. I think it's a step forward over what Jin Wuxio did, where they were, we were meeting with them on a once-a-week basis, but didn't have this kind of systematic approach. And Alex Aris's case studies were more casual partnerships, but didn't have this kind of really engagement in a systematic way. These were, those were people who are closer to us. These people were out of our lab. They're not part of our group. They weren't supporting us. They came to us with a problem. We helped them on their own space, and so it has a greater sense of legitimacy too. Okay, so that's the spirit of this, and we're just sort of good. I'm just trying to make this argument about the shift which we think we are part of. Others have contributed to this also, but the Science 1.0, the physics and chemistry, follows basically a reductionist approach. The Science 2.0 argument says the real problems of our world, healthcare delivery, emergency response, workforce competitiveness, environmental preservation, energy sustainability, on and on, are not, they're not easily decoupled. There's such rich interactions, and so you can't study them in a laboratory. You can look at pieces in a laboratory situation, but basically you want to look at them in situ in the real world. Now that you still can do studies and you can intervene, okay, but they're not the kind of controlled studies, I would say. I mean, there may be elements of it that you can look at in a controlled way, but we think that case studies and the problem with case studies have the high degree of validity. They're real stuff, whereas controlled studies are questionable in their validity. But they have the authority of replicability and the promise of generalizability. So it's those 3 things we're trading off against. And I would say that since this is high validity, the way to get replicability is multiple case studies. And so we think that there are long-term need for major investment in the same way that medical case studies or clinical trials will study thousands of users over a period of years in their real lives, and you spend $300 million. We need to spend that kind of money for this kind of research. These are the problems of the next 300 years, and we should, in medical and in business world, case study research methods are well accepted and part of the literature, and we want to see that happen in many other domains like HCI. So out of the laboratory in a situated, and we're talking about more the natural world as opposed to the made world as the focus of study.
More about that contrast.
Okay, well, Herb Simon talked about the sciences of the artificial, so that's one reference, but he didn't get quite the social dynamics that we're talking about. So the interesting questions for our age are healthcare delivery, right? I mean, I know that genomics is the natural world, but healthcare delivery is a socio-technical system. It involves thousands of people. It involves responsibility, trust, empathy, privacy, collaboration. Those are the attributes that I think we have to study, and you can't study them. They're not part of the natural world. They're part of the made or the human world. And while there are still many open problems in Science 1.0 and the science of the natural world, that really the interesting and important directions for the next 300 years, I suggest, will be these sciences of the made world. I would like a better term. I don't like the artificial, but made world. What?
I see your distinction now, but I think the terminology
Yeah.
leads into. I mean, after all, the social is not artificial.
That's why I don't like
It's not
artificial.
unnatural.
That's right.
Yeah.
That's right.
So
But
I-
in the same way that the study of a plant may be a study of the natural world, but a study of a farm is a made world kind of thing. Okay? Yeah.
I really like this distinction that you are presenting here, but I have not heard this term Science 1.0 and 2.0. So just trying to clarify, are they standard terms?
No, I made this up. This is the third time I've given, and you haven't heard my whole pitch, but I wanted to add this in here. But this is my, I would just say maybe to help clarify, there are things we want to keep as we go across here that I still believe the hypothesis testing a priori, where you say, I'm after this, out to prove this point, and that the goal is predictive theories where I will, or models that will say, I believe that if you make the change in this network system, that you'll increase the privacy or trust or so on. And replications are still an important aspect of it, but we may not get such clean replications as we have, with studying gallium arsenide, crystals in a laboratory setting. So, I'm in the beginning of formulating this notion, and of course this has profound impacts on education and also funding. And that's where the political issues get. I mean, I do want to take the money away from the Large Hadron Collider, and I do want to take the money from the space station and put it to work on what I think are a set of problems. There are further issues about, I think, in Science 2.0, we bring closer theory and applied work, and basic and applied research and theory and practice get closer together. This is a vision that's goes back to at least to Emerson in 1837, whose essay about the American scholar talked about the scholar being a man of action who integrated multiple disciplines and produced benefits in the real world. And I think we need to return to that. Of course, William James, John Dewey, Vygotsky, Herb Simon, and others have, Lucy Suchman, and so on. There's many people who have made such claims, but that's where I'm going with this argument, and I think it's worth making. I think HCI is a paradigmatic Science 2.0 endeavor. We've imported for the first 25 years of this discipline Science 1.0 methods of controlled study. Those are valuable. We need to do that. However, we need to make a safe space in the HCI community for this kind of new forms of research. Okay? Now, there are examples of success stories of that, direction of research, but I think many people feel that the Chi community and others are still not so receptive to this kind of study and push back on the rigors of controlled studies, which I was an advocate and still am an advocate. I have nothing against them, but I do believe many problems are better studied in case study methods. Yeah.
I have a couple of comments. So one is, again, going to this natural world and made world distinction. So I think even in natural world now, people are finding Science 1.0 a bit difficult to apply, and they're moving to Science 2.0.
Okay.
And I do work in linguistics, how languages evolve, and many people would consider or tend to consider it as Science 1.0 for some reasons. But I did find like Science 2.0 is the only way out.
Yeah.
This is one. And another related comment is Daniel Dennett, philosopher Daniel Dennett, has a very interesting lecture saying that this distinction is very fuzzy. You cannot put a boundary between natural world and made
Right,
world.
right. That's right. I mean, that doesn't mean we shouldn't, it's hard to put a distinction between day and night, but we know there are two different states, okay? And, I recognize that this is not perfect, and there are many crossover and complications, but to me, the important thing is making a safer space for 2.0, to make it part of our, I guess, the funding priorities and the political issues as well as education. And I think that's where I am. Come visit us at our 25th anniversary symposium coming up next year. There'll be many parties arranged by Allison Druin, who's director of the lab now, and we'll take it from there.
I'll get it on my calendar.
All right. Good.
We'll book the suite. Well, I guess let us all express our appreciation for this presentation.
Thank you, thank you, thank you.
Thank you very much.
All right.